Hi, welcome to the third topic in this first unit, acceleration. Now, the first thing you got to realize is uniform motion that we've talked about is motion that only has one velocity. You stay at the same speed. Now, nothing in the real world ever stays at the same speed for very long. In order to actually make movement useful, we speed up, we slow down, we change direction. Even when you're walking, you may think you're at a constant speed, but you're actually speeding up slightly every time you take a step forward as you accelerate up, and you slow down as your foot hits the ground again. So we need a way to describe motion that doesn't stay at the same speed. So because we're not staying at the same speed, we need two velocities. We have an initial velocity, which is v1. That's the velocity at the second you start measuring. The final velocity, or v2, is the velocity when you stop measuring. So start is v1, stop is v2. By the way, keep an eye, the one trick I can ask on these questions is v1 or v2 could be 0. So if you hear me say starts from rest or comes to a stop, starts from rest means v1 is 0, comes to a stop means v2 is 0. So acceleration is the rate of change of velocity. It's how fast your velocity is changing. So it's not how fast you're going, it's how fast you're speeding up or slowing down. And sometimes being able to change velocity quickly is more important than what the final velocity actually is. Good example is football. It's why we always talk about someone being fast or quick. Fast means you have a big V2, a big top speed. Quick means you can get off the blocks really fast and you can get by people. So acceleration, in fact, is how we measure cars, right? When we say 0 to 60 in 4.2, that's actually telling you an acceleration. So how do you find it? Well, the equation is acceleration is final velocity minus initial velocity divided by the time. So v2 is your final, v1 is your initial, t is your time. So to find it, you just plug in the numbers there and run them through a calculator, and that'll tell you acceleration. The unit for acceleration, because we're dividing meters per second by seconds, is meters per second squared. So here's a good example. Note it's the exact same format that I said for problem solving. Write what you know, write what I'm asking you to find, write out the equation, plug in the numbers, get an answer, give me a statement. So if a Viper can go from 0 to 100 kilometers an hour in 4.2, what's its acceleration? So v1 is 0 because that's where we're starting. v2, 100 kilometers an hour. Now, to actually solve that, we need that in seconds, just like the time. So the way we go from kilometers an hour to meters per second, we divide it by 3.6. So it's 27.8 meters per second. And don't forget, it's the direction. It needs, no, it's going forward. You don't want your car in reverse. It's forward. Time is 4.2 seconds. We're looking for acceleration. So we write out the equation as acceleration v2, v1, and t. Don't forget, sub it exactly as you see it. Biggest mistake people make is they'll sub in v1 first. So it would be 0 minus 27.8. That's not right. You're not slowing down, you're speeding up. So plug in the numbers, run through a calculator, give me an answer. Don't forget the units, meter per second squared, and the direction forward. Every question will basically be like that. You just plug in the numbers. So here's another question. A cyclist traveling at 14 meters per second forward slows down to 4 meters per second forward in 3.2 seconds. What's their acceleration? Well, again, v1 is 14, v2 is 4, t is 3.2. What's the acceleration? Write out the equation, plug in the numbers. Remember, v2 first, then v1, divide it, and you get minus 3.1 meters per second forward. Now, you might ask yourself, wait a minute, negative? Does that mean she's going backwards? No. She's always going forward. She starts at 14, she ends at 4. What a negative acceleration means is that your velocity is decreasing. So a negative acceleration means you're slowing down. A positive acceleration means you're speeding up. So you may have heard the word deceleration. It really doesn't exist. There's no such thing as deceleration. It's just a negative acceleration. So negative acceleration means you're slowing down, positive means you're speeding up. So that's actually a really good way to test your answer, is that look at the question and say, is the object really speeding up or slowing down? If it's speeding up, it should be positive. If it's slowing down, it should be negative. If it's not, chances are you subbed your V1 and V2 in wrong. All right, thanks. Good luck with the questions.